Hello everybody, welcome to our second video on our series on mineral grinding and the sagmilling.com software. This video describes some of the basic concepts of mineral grinding and the basis of the specific energy models. This is an introductory video and it is not necessary to have watched the previous videos to understand this one. We'll start by having a look at this dacite rock example. And we're going to talk about what the purpose is of the grinding circuit within a mineral processing plant. The rock, you can see, has some large crystals in it embedded in a matrix of finer material. Our objective is to liberate out of the matrix these coarse crystals. We're trying to separate out individual crystals so that they can then be separated into the ore-bearing minerals and the not ore-bearing minerals. This is an example of a porphyritic rock where you can see sulfide mineralization along a vein structure kind of running through the middle of this sample. And if you know what you're looking for, you can also see there's some brecciated chunks in here that are going to have potentially a different characteristic to the overall ground mass. This ground mass has a lot of quartz in it, and then there's some feldspar as well. This third example is one of my favorite rocks in my collection. It's a piece of PQ drill core from another copper porphyry. And what you can see in here is some fracture surfaces that when you actually hold the specimen in your hand, okay, so this is the actual specimen right here. You'll see that there's some void spaces and actual fracture surfaces along a couple of these fracture planes within the rock. There's also some, let's call them healed fractures, like this white band through here is a completely recrystallized quartz structure, which is not likely to break easily in the rock. If this particular sample was to go into a grinding or crushing machine, the first place it's going to break is along these fracture structures. So here's a diagrammatic example of a piece of drill core I'm going to use this as a prop to describe the way that we can use specific energy models to predict the grindability of a rock specimen like this. So what you're seeing here is, again, some coarse fractures that would have been caused by, let's call it the stress regime or the tectonic environment that this rock lives in. We've got some coarse brecciated particles, which the individual clasts that you're looking at here, they might be softer than the ground mass, they might be harder than the ground mass, but they're probably going to have a slightly different grindability characteristic to the overall rock, especially along these boundaries. You might get a preferential breakage right around these boundaries. And then finally, you've also got this ground mass of grains that once you've broken down to, you've broken all these brecciated particles out and you've broken them down, the last thing you're going to have to do is start popping apart these individual grains and separating them into individual grains. And in something that's a coarse sandstone, like this diagram shows some pretty coarse particles in the ground mass, you might actually have to start breaking those open depending on what it is you're actually going after. So from a modeling standpoint, if I'm going to describe how to break this rock, I need to have a laboratory test that tells me the competence of these fracture structures. That's going to be one number. I'm going to need a second number that describes not just the competence of these brecciated particles, but how well they detach from the overall ground mass. And then finally, I'm going to need a third number that describes breaking apart this ground mass, right? Ripping apart the matrix of this rock. So this example, if I'm doing a specific energy model, I'm going to be looking for three parameters to describe this rock breakage at the coarse size, the fractures, at a medium size, these brecciated chunks, and at the fine size, which is disintegrating the matrix of the rock, getting down to the actual individual grains. Here's an example of a laboratory test rig that's used in what's called the Bond Low Energy Crushing Work Index test. This is one of the machines that can give you a number that will be used in models to represent, for example, that coarse size where you've got fracture-dominated breakage or separating brecciated particles out of the matrix of the rock. This is one of the few tests that operates in this size class and is generally used in bond type models. And this is a test rig for the Bond Rod Mill Work Index test. It operates in the medium size class and is generally used to give you the breakage characteristics of, in the case of our brecciated particle, it would be separating that brecciated particle out and breaking those brecciated particles. In a non-brecciated particle, it's really used to give you what the matrix competence of the rock is, pulling apart those individual grains that you would see in an example rock. This apparatus is the Bond ball mill test rig, and it's about the only test that people use in the really fine size class. So this is used for separating individual grains away from the ground mass of a rock. And it can also be used, if you go down finer than the grain size, to tell you what the breakage characteristics are of breaking individual grains. This is a drop weight test apparatus which is used in, for example, the SMC test. And it gives you a breakage characteristic that is kind of similar to what you would get out of the Bond rod mill test. It operates in generally the same size classes. And it would be used in, for example, a Mineral MI model to do the same job that the Bond rod mill test would be used for in a bond type model. So this is an example of a SPI mill, and this operates in basically the same medium size class that the Bond rod mill does. And it's used in, for example, the Amundsen SGI model to give you that intermediate size class breakage characteristics. It's also used in the seat model, which is used in some of SGS's solutions. So basically there's three tests that are used for that intermediate size class depending on what type of a model you use. There's a rod mill for bond models, there's a drop weight tester for MI models, and there's this SPI or SGI mill used for SGI type models. So the final thing we're going to look at is how these laboratory test results appear in models. So I've pulled up the wiki page for the sagmilling.com software where you can see that there's a variety of specific energy models that are configured in the software. And each one of them will have its own particular set of equations. And the test results that we see appear in the components of the equations. So here's an example of the Agnico Eagle's SAB circuit, which is just some published information, which I've grafted onto it. Some other published information for some grindability testing was done at Labrances in Chile. The Labrances test work is particularly interesting because it has the Bond series of tests, crushing, rod mill, and ball mill. And it also has done the SPI series, which we can use in an Amundsen SGI model. So there's the SPI value that would have come from the SPI mill, along with the Bond ball mill test. So this is an example of a two-parameter model where you don't have a coarse measurement, but you do have a medium and a fine size measurement. And here is the Mineral MI model, where again we've got an MIA value which comes from the SMC test. And we also have a coarse measurement here, this MIC value that reflects some crushing information. This actually does come from the SMC test. So the one test gives you two values. And then we have a third value here comes from the Bond ball mill test, but it goes through an equation for a Bond MIB number. And again, that's described in the laboratory test procedures for the MIB test. and it goes through a whole bunch of these equations. So for people who want to dig into the equations, I'll put a link to the wiki page. The key thing you need to know if you're using the software, if you enter all of this lab testing, it automatically gets dropped in the right models in the right places. So that's going to be it for today's video. I hope you've learned something interesting here about the different types of grindability tests and seen the process we go through to conceptualize how these models are constructed. I hope to see you in the next video.